Okay, good morning, everyone. So we are going to talk about elimination of arbitrary constants. And after this, we will be solving problems involving families of curves. Okay, so let's start. Okay, so our objective here is how to arrive at a differential equation. Okay, so this is useful in the sense that it will give us, a feeling of solutions to be expected. So what are the characteristics of an ODE? Okay, so utilizing this technique and how to arrive at its differential equation. So the order of the DE is equal to the number of arbitrary constants. For example, if the given equation contains two arbitrary constants, so it means that we are expecting a second order differential equation. If the given equation or solution is um, or contains three arbitrary constants, it means that the ODE of that solution is a third order differential equation. If it contains one arbitrary constant, then it's a first order differential equation. Okay, now what are the other um, criteria or characteristic? It's consistent with that relation. And lastly, free from arbitrary constants. So you have to take note that the ordinary differential equation should not contain an arbitrary constant. That's why we have to eliminate the arbitrary constants once that we have undergone the first step, okay? Or the major rule, which is by differentiation. Okay, so now let's recall this example that I have explained to you last time. So find the ordinary differential equation by eliminating the arbitrary constants. So this is our given. Y is equal to c sub 1 x squared plus c sub 2 x plus c sub 3. So notice that the given equation contains three arbitrary constants. Right? And what are these arbitrary constants? So we have c sub 1, c sub 2, and c sub 3. So it means that we are going to differentiate the given equation three times, okay, for us to arrive at its differential equation. So again, the order of that differential equation depends on the number of arbitrary constants present in the given equation. Okay, now let's proceed to the differentiation. So this is actually one rule that we can follow for us to arrive at its differential equation. So you just have to differentiate the given equation as many times depending on the number of arbitrary constants. That's why it says here differentiate three times. Three times because of the three arbitrary constants that are present in the equation. So we have the first derivative of this given equation. Okay, take note that y here is the unknown function and x is the independent variable. Okay, now this is the first derivative of the given equation. So y becomes y prime. This term here, so just copy c sub 1 and differentiate x squared, and that is 2x. The second term here is c sub 2x. So to differentiate this, you just copy constant and differentiate x with respect to the independent variable x, and that is 1. And last term here is a constant. So differentiating a constant means the value is 0. Okay, now this is the result of first differentiation. So we still need to differentiate this two more times. So the next one, differentiating y prime, will give us y double prime in this right-hand side of the equation. So you have 2 c sub 1 x Differentiate this, just copy 2c sub 1 and differentiate x with respect to x. That is 1 plus the derivative of a constant is 0. Okay, so this is the result of our second differentiation. Now, finally, okay, so this is now um, the final equation here. So if it happens that this final equation contains arbitrary constant, then okay, so you should stop differentiating that equation. Instead, you are to manipulate the equation or do substitution or utilize the previous equations for you to be able to determine the final answer or its differential equation. But in this case, since after differentiating the given equation for the second time, we were able to have this equation containing constants on the right-hand side of the equation. So it means that if you differentiate this one, it becomes 0, right? Derivative of a constant is 0. On the left-hand side, so the derivative of the second or y prime is y triple prime. So we're able to follow the rule, which is to differentiate as many times depending on the number of arbitrary constants. Again, that's the main rule here. Okay, so you check for the number of arbitrary constants. So if there are 3 arbitrary constants, it means that you are to differentiate 3 times. If there are 2 arbitrary constants, it means that you are to, or you have to differentiate twice. If there's only 1 arbitrary constant, so you must differentiate it once. Now that we have this equation, and this final equation here does not contain an arbitrary constant, then this is our final answer for this particular solution or equation. Okay, so this equation, um, y equals c sub 1 x squared plus c sub 2 x plus c sub 3, its differential equation is y triple prime equal to 0. Okay, so this is not always the case. Okay, this is just a a simple way of arriving at a differential equation. This example that by just doing differentiation alone, you were able to determine its um, differential equation. Okay, so as you notice, there is no arbitrary constant in the final or the differential equation. So it's um, it's consistent also with its relation. So this is your final answer. Now I have here in the next slide, I have recorded a video solving some of the examples for arriving at a differential equation. So the first one here is y equals a cosine of x plus b. So I have here a trigonometric function, and a here and b are constants or arbitrary constants. Okay, since I have 2 arbitrary constants in this given equation, now it means that for me to arrive at its differential equation, or for me to be able to obtain its differential equation, so I should differentiate this 2 times or twice. Okay, now let's proceed. So I'm differentiating now. So y becomes y prime equals the right-hand side, so just copy a and then differentiate cosine of x plus b. So remember, the derivative of a cosine is negative sign. So this x plus b here is the argument. So we just have to copy, okay, cosine x plus b. X plus b is the argument, or yeah, the angle of this trigonometric function. So the derivative of cosine is negative sign. You just copied the constant a. And then, of course, you are to differentiate x plus b with respect to the independent variable. And that is equal to, okay, 1. Now, this is the result of first differentiation. So we have 2 arbitrary constants. It means that we are to differentiate twice. So the second derivative of y is equal to, you copy negative a and then differentiate sign, and that is equal to cosine of x plus b. Okay, and differentiate again x plus b, that is equal to 1. Now, so you stop here. Okay, you stop differentiating. Now you observe the resulting equation. Still, there are arbitrary constants. So what must you do? Okay. Again, the final answer or the differential equation should not contain arbitrary constants. Now observe the previous equations, or you can observe the first equation, or you can utilize, the other equations to eliminate this part here. Now, as you notice, our given equation is y equals a cosine of x plus b, right? Now, our final equation here, the derivative or the second derivative of y is equal to negative a cosine of x plus b. So what's the difference between the first and the last equation? Okay, again, your final answer is a differential equation. So it should contain a derivative. So this should be our final answer. However, because of these arbitrary constants, this is not acceptable. So you have to eliminate the arbitrary constants. So comparing this equation to the first equation or the given relation that we have, then the difference is just a sign, right? So a cosine of x plus b is actually equal to y. So you replace this part in the right-hand side of the equation by y. Okay, do you follow? Now, okay, so we can say, okay, there you go. So a cosine of x plus b is actually equal to y. Therefore, your final answer here is negative y. Okay, so that's your final answer. And that equation does not contain an arbitrary constant anymore. So a differential equation contains a derivative. So tama naman. Then you transpose negative y to the left-hand side. So you can arrange your answer into that format. Okay, so y double prime plus y equal to 0 is your final answer. Okay, so any question before we proceed to the next example? Questions?
Or laging substitute lang po sa y lang po yung pagpareho lang po.
Um, ano po ulit? Substitute to, it depends. Okay, well, as you observed that the given equation is actually what? Somehow similar to the final answer. So you should substitute. Okay, so what other way that you can do? So you can utilize the other equations. So yung previous example, so you have observed that the given equation is, somehow similar to the final equation after, differentiating that equation for its required number of times. Okay, so just like another example here, so you will see that the result here will be similar to the given relation. So take a look at this example. So we have y equals, anyway, I was able to, are you satisfied with my answer? Okay,
Yes po, sir.
okay, so great. Now we'll have another example later that, will not utilize, the first equation as, to help us obtain or arrive at our final answer. So this another example is we have an exponential function y equals c sub 1 e raised to x plus c sub 2 e raised to negative x. So remember how to differentiate an exponential function, okay? So the same process, the constants are just being copied. So c sub 1 e raised to x, and then differentiate x, okay? And that is equal to 1 for this instance. And then the second term, c sub 2 e raised to negative x. You copy c sub 2 and then you copy e raised to negative x and differentiate negative x, and that is equal to negative 1, right? Okay. Okay, excuse me lang. Mute lang muna natin lahat. Okay, so let's continue. Sorry for that. So if you have nothing to say, please continue to mute your microphones. If you have any questions, you can raise your hand or interrupt me, okay? Thank you. Now let's proceed. This is the first differentiation. So the question is, how many times do we need to differentiate this given equation? Anyone?
2 times
Two
po,
times.
sir.
Okay, so twice or two times only because of the two arbitrary constants that you can see in the given equation or solution or function or relation. Anyway, so let's proceed to the final differentiation. So y prime, the derivative of y prime is y double prime. And then differentiate the first term at the right-hand side of the equation. So we have c sub 1 e raised to x, differentiate x at the exponent that is equal to 1. So minus, we copy c sub 2 and then differentiate e raised to negative x and then differentiate negative x and that is equal to negative 1. So negative times negative, you have a positive, sign here. Okay, so what have you noticed? So you can see that y double prime is actually equal to y, our given equation on the first line here. So it means that y double prime is equal to y. So the question is, why did we do this? Because we don't want to see an arbitrary constant in our final answer. Because having arbitrary constants in our final answer in a differential equation is not acceptable. So in our rule, it should be free from arbitrary constants. That's why we take a look at some of the equations, okay, like the given or the second, so whichever is helpful in arriving at our differential equation. Okay. So you may do substitutions. Now we have this one, so y double prime minus y equals 0. So this is our final answer. Okay. Okay, I'm back. Now let's proceed to our next example. Okay, yeah, somehow similar along this, but as you can see, the exponential functions here, e raised to 2x and e raised to negative 3x. Okay, now let's proceed. So there are two arbitrary constants. It means that we are to differentiate this 2 times. Okay, so clear na tayo dun sa idea that our differentiation process depends on the number of arbitrary constants. Okay, so don't just differentiate as many times without considering the number of arbitrary constants. Okay, so that's our main rule here. Now we differentiate, we have y becomes y prime equals the first term here on the right hand side, so c sub 1 e raised to 2x, differentiate 2x, and that is equal to 2. Okay, so on the second term at the right-hand side, so we have c sub 2 e raised to negative 3x. You copy c sub 2, and then differentiate e raised to negative 3x. You just copy first and differentiate negative 3x, which is equal to minus 3. Okay, so this is the result of our first differentiation. So you can label this as your equation number 1. Now, finally, we differentiate this. Y prime becomes y double prime. The first term here is 2c sub 1 e raised to 2x. So we copy first 2c sub 1 or copy c sub 1 and then differentiate e raised to 2x. So what I did here, since my coefficient siya na 2, so I'll differentiate first e raised to 2x. That is e raised to 2x times derivative of 2x is 2 times 2 becomes 4. So this is our first term. Now for the second term, we have e copy c sub 2 and then e raised to negative 3x, differentiate minus 3x, and that is minus 3. Minus 3 times minus 3, you have positive 9. Okay, so this is now our second equation. So you can label that as equation number 2. Okay, so you stop there. Okay, you don't need to differentiate anymore. So the next step will be how to eliminate those arbitrary constants, c sub 1 and c sub 2. So you can do substitution or whatever manipulation, okay, the right manipulation of the equation. So here you can observe the two equations. Okay, so as you can see, for you to be able to eliminate this part, so you are to multiply the entire equation 1 by 3, right? So that they become, like terms. So, and then with different signs, you can be able to cancel this one. And if you want to eliminate the first term, c sub 1 here, you need to multiply the entire equation 1 by minus 2, and then add them to eliminate this one, or you can multiply by positive 2 and then you subtract. Okay, so do you follow? So basically that's, the most convenient way for you to be able to eliminate. So let's continue. So here we will solve for, it depends on, what you want to eliminate first. So if you want to eliminate c sub 2, so you solve for c sub 1 e raised to 2x. There are many techniques or methods that you can do. Well, I'm showing you how I solve this one. So to solve for c sub 1 e raised to 2x, I will multiply the entire equation 1 by a factor 3 to make them similar, okay? And then I will add equation 2 in the first equation, having multiplied it by 3. So now what I'm doing here is multiplying the equation 1 by 3. So we have 3y prime equals 3 times 2 is 6 c sub 1 e raised to 2x. And then minus 3 times 3, you have minus 9 c sub 2 e raised to negative 3x. Okay, so the next step will be to add equation 2. So you copy y double prime equals 4 c sub 1 e raised to 2x plus 9 c sub 2 e raised to minus 3x. And then you just add them, combining like terms. Okay, so 3y prime plus y double prime. So there's no similar terms there, just copy them. I add them. In the first term, so you have 6 and 4. So you have 6 plus 4 is 10, c sub 1 e raised to 2x. And here for the second terms of each of the equations, you can be able to cancel that since minus 9 plus 9 is 0. Okay, therefore, if you are to solve for c sub 1 e raised to x, you divide both sides by 10 to remove the coefficient there. Coefficient na 10. Okay, so you have 3y prime plus y double prime all over 10. So this is our, this is the value of c sub 1 e raised to 2x. Now the next step is, as you can see here, I have written again the two equations for you to be able to see, and you have a reference for the next step, and that is to solve for c sub 2. Okay, so you solve for c sub 2 e raised to minus 3x. Okay, so it means that we are to eliminate here c sub 1. Okay, so for us to be able to do this, we can subtract these two equations. And first, you have to multiply the first equation by 2, and then you subtract, or I mean, if you want to add, so you should multiply the entire equation 1 by negative 2. So you should, multiply equation 1 by minus 2. And then you add the entire equation 1, you add equation 2, okay. So first, you multiply the entire equation 1 by negative 2. So you have negative 2y prime equals negative 2 times 2, you have negative 4 c sub 1 e raised to 2x. Negative 2 times negative 3, so you have positive 6 c sub 2 e raised to minus 3x. Okay, and then you add now equation 2. So just copy y double prime equals 4 c sub 1 e raised to 2x plus 9, okay, plus 9, c sub 2 e raised to minus 3x. Okay, so as you can see, there are like terms there. On the left-hand side, so you have minus 2y prime plus y double prime. So no similar terms, you just copy them. So minus 2y prime plus y double prime equals, so as you can see on the first terms of the two equations, so minus 4 and plus 4. Yes, you can be able to cancel that one. And then 6 plus 9. So you have 15 c sub 2 e raised to minus 3x. Okay, do you follow, guys? Do you have any questions so far?
Wala po.
Okay, so that's good. Now, since we are to solve for c sub 2, and we can see that there's a coefficient there na 15. So we multiply or divide both sides by 15. So we have, okay, so wait a moment. Let me just correct the video here. So it should be c sub 2 e raised to what? Minus 3x. Okay, now let's continue. Okay, so you have minus 2y prime plus y double prime all over 15. Okay, so this is now the value of c sub 2 e raised to minus 3x. Okay, now the next step will be to substitute these values in c sub 1 e raised to 2x and the value of c sub 2 e raised to minus 3x to our given equation. Okay, and that is y equals c sub 1 e raised to 2x. Ito yung given natin, right? So c sub 2 e raised to negative 3x. So you plug in all the values of, c sub 1 e raised to 2x and c sub 2 e raised to minus 3x. So you have the first term. If you still recall, the value of c sub 1 e raised to 2x is 3 y prime plus y double prime. So mas maganda, di ba? If you have a paper and pen there, you can also, while I'm discussing this, you can also copy or solve on your own. Okay, so you can verify later if your answers are the same with my solution. Okay, now so let's continue. Sir Phil, continue na po. 3y prime plus y double prime all over. Okay, what is that factor there? So 10 plus the value of c sub 2 e raised to minus 3x is actually minus 2y prime plus y double prime all over 15. Okay, so okay, what can you say about the resulting equation? There are no arbitrary constants, right? Okay, it's qualified to be a differential equation since there are derivatives, okay, ordinary derivatives in the equation. But the next step will be to simplify. Okay, that's a challenge now, yung sa pag-simplify. Simplify ng final answers. Okay, so let's erase first this part here. Okay, wait a moment. Let's also erase the annotation that I have made earlier. Okay, let's continue. Now, what we're about to do is to simplify this final answer of this equation for us to be able to enclose our final answer for this particular problem. Okay, so just copy again the equation below. And then think of, the least common multiple that we can multiply the entire equation to. Okay, so 10 and 15. What's the least common factor there that we can multiply?
30.
30, right? So if you multiply 30, both sides of the equation, so we can be able to, okay, we have the result here. So left-hand side, so 30 times y, so you have 30y. So algebra na tong part na to, guys. So no worries. If you're good in algebra, then nothing to worry. So here 30 divided by 10 is 3. So multiply to 3y prime plus y double prime dun sa numerator plus 30 divided by 15. That is equal to positive 2. So you copy 2. You just put 2, then minus 2y prime plus y double prime. Okay, that's it. Now, this is not your final answer yet. So distribute natin yung 3 and 2. So 3 times 3, 9 y prime plus 3 y double prime. And we have 2 times negative 2, so you have minus 4 y prime plus 2 times 1, you have 2y double prime. Then combine like terms. So we have y double prime, y double prime. We have y prime and y prime. Then we combine them, so you have 30y. Okay, 9 minus 4, so you have 5y prime, right? And then 3 plus 2, you have 5y double prime. So as you can see, there's still a common factor there, right? So you can divide both sides by 5 to further, arrive at our final answer, which is, so 30 divided by 5 is 6y, okay, equals 5 divided by 5, so 1, so y prime plus y double prime. This is our final answer. You can arrange your final DE, okay, from the highest derivative to the least. So y double prime plus y prime transpose 6y, so minus 6y equals 0. Okay, so this is a differential equation. It contains derivatives and no arbitrary constants that you can see in the final answer. Okay, clear? Okay, nakuha na yung technique. Nagets nyo na? Okay, so again, so we'll have your first quiz next meeting. So you can start, doing the quiz next meeting, and yeah, basta before the prelim exam, you can be able to finish the quiz. Okay? Doesn't mean na kapag nag-open na yung quiz, mag-take na kayo kaagad, but you make sure that if you're to take, ready kayo. Okay, because there's a time limit there, I think. So 1.5 hours lang siya. Okay, any questions here? Let's proceed to the final example for this particular topic, elimination of arbitrary constants. So, bakit bumalik? Okay. Sorry for that. Okay, let's continue. Our next example is, okay, the equation contains two arbitrary constants pa din. So C sub 1 and C sub 2. So it means that we are to differentiate this equation 2 times. Okay? So first derivative, okay, remember chain rule. So 2 times x minus c sub 1. Derivative of x minus c sub 1 is 1 plus, 2 times y minus c sub 2. Derivative of y minus c sub 2 is y prime, since our unknown function is y, kaya may dy over dx ka dyan. And derivative of 1 on the right-hand side is 0. So as you can see, you can cancel 2 there since common sila. If you divide both sides by 2, yan. So before you proceed to another differentiation, so x minus c sub 1 plus y minus c sub 2 times y prime equals 0 divided by 2, or 0 times 1/2 is still 0. Then we proceed to the next differentiation. So you can label the first, this equation as first equation, or equation number 1. Differentiate x, so we have 1. Differentiate c sub 1, so we have minus 0 here. And then using product rule for the second term, so you have udv plus vdu na technique. So just copy y minus c sub 2. Okay. And then here, so udv, diba? So copy this one, y minus c sub 2, differentiate y prime, you have y double prime. And then you copy this, y prime, and then differentiate this part of the term. So derivative of y minus c sub 2 is y prime. So you have y prime times y prime, or you can say, you can write that later as y prime squared equal to 0. So this is now our final, differentiation step for this particular problem. So you just rewrite first, so y prime squared. You may put, or you may enclose that into by parentheses, or you may not. Okay, so the next step will be to be able to eliminate the arbitrary constant c sub 2 and c sub 1. So we can use equation 2 here. to solve for um, y minus c sub 2. Okay, so I decided to use this because I'll be utilizing later the first equation. So it means that for me to be able to, uh, so I'll be determining x minus c sub 1, I'll be determining y minus c sub 2 and plug it in here later. And that is, if I can do that, then the equation is free from arbitrary constants. So first, I'll be solving for y minus c sub 2 using equation number 2. So what I will do here is, okay, so after doing that, I will substitute this to equation 1 since you have y minus c sub 2. So basically, I'm doing substitution here. Now, so I have here y minus c sub 2. Take a look at the second equation here, times y double prime. Okay. And then I will transpose 1 and y prime squared to the right-hand side. So you have y minus 1 minus y prime squared. Okay. So pwedeng ganito yung pagkakasulat ng y prime squared. Okay, need not to put a parenthesis there. Now, let's continue. Okay, so to solve for y minus c sub 2, I will divide both sides by y double prime. Okay, kasi may y double prime ka dito. Then you have y minus c sub 2 equals, okay, common yung negative signs, you can factor out minus sign there. So minus times the quantity 1 plus y prime squared. Okay. Now, and all over y double prime. So I have now y minus c sub 2. So I can label this as my equation number 3. Now, after this, I will substitute this y minus c sub 2 to the equation number 1. So as you notice, there is x minus c sub 1. So you copy x minus c sub 1 plus, what's the value of y minus c sub 2? That is negative times the quantity, okay, 1 plus y prime squared all over y double prime. Of course, you have to multiply that by y prime here, equal to 0. Now, my objective here is to solve for x minus c sub 1. So what I will do is transpose this term to the right-hand side. That's why I have here x minus c sub 1 equals, transposing this term, na negative sign siya, magiging positive. So 1 plus y prime squared times y prime all over y double prime. Okay, so now I have the value for x minus c sub 1. Okay, so let me label this as my equation number 4. Now I have the last two equations, 3 and 4. So I will substitute equations 3 and 4 to the given problem, which is x minus c sub 1 raised to 2 plus y minus c sub 2 raised to 2 equal to 1. Okay, now I will plug in all the values from equations 3 and 4 to this given problem. So I have x minus c sub 1 is equal to 1 plus y prime squared times y prime all over y double prime. So don't forget, raised to 2 yan. So this term has a power of 2 plus y minus c sub 2 is equal to what? And close that into a bracket. So minus times the quantity 1 plus y prime squared. Okay, all over y double prime raised to 2 equal to 1. Okay, I think Sir Phil, nakalimutan mong lagyan ng exponent 2 yung second term. Okay. So the next step will be, okay, to simplify na. Okay. Ayan. So naalala ni Sir Phil. You have to put 2 there, the second term. Okay, yung next step natin is, ayun na, it's actually the differential equation, pero para magulo tignan, di ba? So you have to simplify this one to arrive at its differential equation. So wala nang arbitrary constants dyan. What we're doing here is to simplify. Now, we apply first yung mga exponents na 2 na yan. So ibig sabihin, this first term will become 1 plus y prime squared. And ayan, ganun din, y prime squared, and then all over y double prime squared. Okay, so the second term, if you are to square this one, so yung negative, matatanggal na yung sign dyan. So magiging 1 plus y prime squared raised to positive 2 all over y double prime squared. Okay, equal to 1. Now, the same denominator ng dalawang terms natin, so you can multiply both sides by y double prime squared. Then we have 1 and 1 plus y prime squared raised to positive 2 times y prime squared. Tanggal na yung denominator, di ba? Since we are to multiply this one by this factor. Second term, we have 1 plus y prime squared raised to 2 equals y double prime raised to 2. Okay, so ayan na tayo. We are about to realize the final answer. So here, observe natin itong left-hand side. So as you can see, you have, okay, may common sa kanila, right? Yung first term natin, merong 1 plus y prime squared raised to 2. Yung second term natin is meron din na quantity 1 plus y prime squared raised to 2. So you can actually factor out, naka-group na yan sila. Okay, so let's continue. Nakita niyo ba? Ang tinutukoy ko, that you can actually simplify that. You can factor out 1 plus y prime squared raised to 2. So ayan na. So y prime squared, if you factor out, so magiging, yung matitira sa first term is y prime squared plus 1 plus 1, okay? Equal to y double prime squared. Okay, I think Sir Phil, nakalimutan mo na you have to factor raised to 2. Ayan. So dapat may raised to 2 dito. Ayan, so mabuti na alala ni Sir Phil. Okay, so again, just to remind you of what I just did, common yung 1 plus y prime squared. Okay, ito yung first term, ito yung second term. Nakuha niyo yung technique na to, so i-factor out natin. So just factoring out, okay, this part here. So factoring out, meron tayong matitira sa first term, which is y prime squared. And then factoring out this one, anong matitira dito? You have 1. So what have you noticed? The same lang sila, di ba? Kahit magkaiba lang yung order. So y prime squared plus 1 or 1 plus y prime squared. It means you can combine this, right? So the same base, different exponents. So law of exponents lang. Then you can say that combining them, 1 plus y prime squared, magiging raised to, ano na? Raised to 3, right? 2 plus 1 lang equals y double prime raised to 2. Okay, that's it. Imagine yung napaka-complex tignan na result, we were able to simplify into this format. Okay, or you can say, you put them into a one side of the equation. So y double prime squared transpose 1 plus y prime squared to the other side. So you have minus 1 plus y prime squared raised to 3 equal to 0. Okay, any questions, guys? So ganun lang. May tanong kayo dun sa final answer? None?
Sir, po.
Yes.
Pwede po pabalik dun sa kanina, sir. Dun sa, ano po?
Final answer?
Po, yung malapit po sa final answer.
Okay, where? Saan
Yung
part?
natatakpan po nung kamay niyo nung sa video. Sige po, paano ako? Yung natatakpan po nung kamay niyo dun sa video, yung kulang po na ano, y prime squared. Ayan po, ayan, yung y prime squared po dun sa baba. Ito, sa first na ano.
Ito, first term?
Saan po siya na napunta?
Mm.
Medyo hindi ko po na-gets doon.
Di ba naka-group na to? Di ba?
Apo.
Medyo komplikado lang. Yung first term natin is itong factor na to and this 1y prime squared, right?
Apo. Apo.
Ito naman, ito lang talaga siya. 1 plus y prime squared raised to 2. So,
Apo.
pag nag-factor out tayo, ano bang ginagawa pag nag-factor out? Ilalabas natin to. Parang i-group natin ulit sila. Pag nilabas natin to, anong matitira? Ito na lang yung matitira, di ba?
Apo.
So, ito yon. Ang itong part na to, ito na yon yung first term na to. Nakuha mo?
Okay po.
Okay. So, ito pag nilabas natin, anong matitira dyan? 1, di ba?
Apo.
O, ito yung 1 na yon.
Okay po.
Okay?
Apo.
Ganun lang din. Try mo to i-distribute ulit. Babalik ulit sa ganitong format. This factor multiplied to this one, ito yon, first term.
Apo.
This factor multiplied to 1, ito yung kalalabasan nun. Okay?
Okay po. Thank you
Sure? Okay, sige, good. Any more questions? So, mabuti na point out mo yun kasi madaming nalilito din sa kanyang part, yung factoring by grouping. Okay? So, madami kayong ma-encounter na ganyan na mag-factor out kayo. Okay? So, ano pa ba yung mga example natin na pwedeng bigay? Anyway, so na-clear na tayo doon sa ganong question. Wala na? Baka nahiya lang kayo. Hello? Hello?
Okay na po, sir.
Wow. Meron tayong spokesperson, si Hamko. Thank you for answering. Ikaw na lang lagi sumagot, ha?
Welcome, sir.
Okay. Si Hamko siguro magaling to, no? Siya yung tagaturo sa classmates niya.
Ako, sir, hindi po.
Galing niya.
Sige, abangan natin sa first quiz. Okay, so I think we're ready for the next part of... Wait lang, hindi ko ma-proceed sa next na slide. Okay, so families of curves. Yung idea naman dito is still, di ba, how to arrive at a differential equation given ka ng family of curves or family of lines, family of circles, or all circles, all parabolas, all ellipses, and all hyperbolas. So all curves or all lines. So dito, hindi ka nabibigyan ng equation. Okay, ikaw yung ikaw maglalagay. You have to recall the equations of the circles, lines, yan. Kung ano man yung tinatanong dun. Okay, dito. And you have to take note, di ba? 1, yung parameter na yan, may ibig sabihin yung parameter na yan. If you can be able to, yan. Let me have this first illustration. So this is a family of concentric circles, okay, na yung center ay nasa origin. So the equation for this family of circles is x squared plus y squared equal to c squared, or pwedeng sabihin r squared. Because, one value of the radius here, since ito yung parang radius natin, okay, nag-represent siya ng isang circle. So it means that the parameter here is actually the radius. Kasi fixed na yung kanilang center, di ba? Walang problema. They have the same center. Do you follow? So the parameter here is the radius. So this equation contains one parameter or one arbitrary constant. It means that if you are to solve or to arrive at this differential equation, you have to only differentiate that once. Okay? Yun yung magiging differential equation niya. So ganun lang. Bibigay sa inyo na problem is find the DE or obtain the DE of the family of circles with centers at the origin. So ito lang yung magiging equation mo. Tandaan nyo lang yan. Okay? And then, kung ilan yung parameters, yun din yung kung ilang beses ka differentiate. So the same with the elimination of arbitrary constants na technique. Okay, now let's do this example. So we have, okay, find the DE for the given family of curves. So much better that you sketch the given family of curves so that you will be able to see kung ano yung mga parameters na involved. Pag sinabing parameter, one value of that parameter represents one curve. Pero kapag constant na talaga siya or fixed na, like the one na yung center, like sa circle, pag pinausapan yung circle, or kaya fixed na yung mismong slope, so hindi siya yung magiging parameter na involved sa mga lines. Okay? Okay, so the first example here is 1, yan, find the DE of all lines, or you can say family of lines that passes through the origin. So, mas maganda i-sketch mo muna para makita mo kung ano yung distinct na parameter na meron doon na pag sinabi natin na one value of this one represents one line, okay? And number 2 naman, all circles whose centers are at the x-axis. So lahat ng circle na yun ay nasa x-axis. Ano yung parameter na involved? Hindi naman nabanggit yung mismong radius ng circle. Ibig sabihin, one of the parameters is the radius. Kasi pwedeng maliit na circle, malaking circle, and medium circle. Basta lahat sila, yung center nila ay nasa x-axis. Okay, that's one way. So kailangan dito ng knowledge niyo about, yung sa geometry, plane geometry. Yan. Mga equations ng circles, lines, parabolas, hyperbolas. Okay, so let's do this one. Let's start first with number 1. Ayan. So naka-gloves na ako kasi nagre-react na yung marker yung ink sa aking kamay. Allergic reaction. Okay, so ang ginawa ko dito is nirecall ko muna yung equation ng lines na applicable or appropriate for this particular na family of lines. Okay, what are the equations ng lines? So very known or well-known yung slope-intercept form. Okay? Do you know this one? Slope-intercept form? Hindi ito given na, so ito lang inirecall ko lang. So y is equal to mx plus b, where m is the, ano yung m? Yung slope. Right? Ano yung b? B is the y-intercept. Okay? So mas maganda na i-sketch natin para malaman natin kung ano ba yung parameter, ano yung constant dyan, hindi na kailangan na hanapin natin yung mismong value niya. Okay? So sketch natin. Sabi, family of lines that passes through the origin. Okay? So I'll draw this one. Ito yung origin, and then I'll draw a line. So yan yung example, di ba? Lahat ng lines na dumaan sa origin. So what do you think is the parameter there? Dumaan sila sa 0, 0, yung common sa kanila. So what do you think is distinct there? Ano yung intercept ng bawat line na yan? Okay, 0, 0, di ba? 0, 0 yung origin, di ba? Yung coordinate, yung ano niya. Coordinates. So, if you are to substitute in this equation, y is 0, x is 0, ibig sabihin the intercept is equal to 0. Okay, nasundan nyo? Guys? Okay. Follow nyo?
Opo, sir.
Yes, sir.
Opo,
Okay.
sir. Opo.
Thank you for answering. Para naman alam kung naintindihan talaga ninyo. So, ibig sabihin, I have here the equation, family of lines that passes through the origin. Ito na yung magiging starting equation ko para ma-obtain ko yung DE. So, as you can see, I have one parameter here. Ano ibig sabihin nito? Nang bawat value ni slope represents one line that passes through the origin. Nakuha nyo? Kasi lahat naman ng line na yan dumaan sa 0, 0. So, intercept nila is 0. Nakuha? But since you know, di ba sa derivative, yung slope, yung y prime is actually equal to the slope, di ba? So kapag ito dinifferentiate natin, y prime is equal to m. Ayan, so tama lang din, di ba, na yung slope is equal to first derivative. Okay? So it just justifies or it just proves that the slope is equal to the first derivative of y. Now, isang beses lang tayo nag-differentiate because of one parameter. Okay? So, ang gawin lang natin, we utilize the first equation here na y is equal to mx, m times x. And that is equal to, yung m is equal to y over x. So, you plug in the value of the slope here in this equation. Ayun na. Yun yung DE, wala ka nang makikitang arbitrary constant yan or any parameter. Okay? So that's it. You can arrange the equation or you can put it in form na mdx plus ndy, or in this case, cross multiply x dy is equal to y dx, or simply y dx minus x dy. Okay, that's it. So that's number 1. Okay, any questions, guys, before we proceed to the next example? Because there are, yung pinaka-ano lang dito, magiging concern natin is, pag hindi mo alam yung equation, ano yung magiging starting equation mo? So yun yung prerequisite dito. Kailangan recall niya yung mga equations. Okay, sa geometry, plane geometry. Equation ng lines, ano yung mga ibang forms pa. Yung mga intercept form pa tayo. Yung slope na formula, pwede nyo rin gamitin yon. Point slope form, alam niyo yon? Na-recall niyo ba yon? Yes. Sige. So walang questions. Let's proceed to the next example. All circles whose centers are at the x-axis. Okay, so ang ginagawa ko ngayon dito is I'm sketching or I'm showing you all circles na yung center ay nasa x-axis. So as you can see, yung mga circles na to, di ba? Hindi naman sila pare-pareho ng mga radius. Unless na nakaspecify. That's one thing pa. Kasi pwede rin na sa problem, bibigay sa inyo, constant yung radius. So yun yung possibility. Tapos isa na lang yung magiging parameter dyan. But in this case, hindi nabanggit na pareho sila ng radius. Ang nasabi lang dito is, yung center ng bawat circle ay nasa x-axis. So ito yung x-axis. Okay, pwede rin sa quiz niyo. Ang ibibigay ko naman is nasa y-axis naman siya. So ayan. So kapag hindi sa origin yung center, ano ibig sabihin nun? HK, di ba yung center? Alam niyo ba yung HK? Hello? So
Medyo
this,
tanda pa, sir.
ayan, good. Kaya dapat balikan niyo yung ano niyo, math for engineers niyo. Okay? So ito, what I have just written here is the equation of the circle kung saan yung center ay nasa HK. Okay, yung H para dun sa X na coordinate, tapos yung K naman is for the Y coordinate. Okay? Yung center ng circle so HK. Ngayon, ang tanong dito, one of these values here or ordinates ay fixed na. Okay, kasi nga x-axis lang naman hindi naman nabanggit na kung saan ng part ng Cartesian plane or may specific point ba na nilagay. Kung may specific point, edi much better. So, isang parameter na lang yung magiging concern mo dito, yung radius. Dito, you have the radius and you have one of these values. Okay? So, ano sa tingin nyo? Ano yung center niya? Ano nagbabago dyan? Nagbabago dito is yung value ni h, di ba? Kasi nasa x-axis, di ba? Yung y naman, fixed na siya na 0. Di ba? Itong part na to, kunyari negative 3 ito. Negative 3, ano yung value ni y? 0. Ito kunyari negative 2. Negative 2, 0 pa rin yung k mo. Ito negative 1, 0. Ito naman positive 1, 0 pa rin yung y mo, yung k mo. Nakuha nyo yung I point ko? Ibig sabihin, fixed na yung k. So, instead na meron kang tatlong parameters, you have x minus h raised to 2 plus y. 0 tong k na to, so y squared na lang siya equal to r squared. So here in this equation, ito na yung gagamitin mo na equation. Okay, examine mo to. Ilan yung parameters dito? Yung value ni h, tsaka yung value ng radius. So one value of the h and one value of the radius represents one circle. Nakuha nyo? So there are two parameters here. You have... Nasundan nyo ba, guys? Clear naman, no?
Opo, sir.
H and R. So, yun yung parameters natin. Ibig sabihin, sa dalawang parameters ko, dalawang beses ako mag-differentiate para makuha ko yung kanyang differential equation. So, here, I'm now differentiating 2 times x minus h, tapos differentiate x minus h. Second term is y squared, so differentiate y squared, that is 2y prime. Differentiate the radius, since radius is constant, arbitrary constant siya, so 0. So yan ay result ng first differentiation. So here you can actually cancel 2 or divide both sides by 2. So before you differentiate for the second time, so copyhin muna natin. And then we finally differentiate for the second time. So derivative ng x is 1, derivative ng h is 0. And for y prime, product rule ulit tayo, udv plus vdu. So y times y double prime plus y prime times y prime. So magiging y prime squared. So as you notice, by just differentiating, tanggal na natin yung arbitrary constant. So wala na. You just have to arrange your equation. So y double prime plus y prime squared plus 1 is equal to 0. So this is now our differential equation for all circles whose centers are at the x-axis. Okay? Nasundan ba? May tanong ba dito? May hindi ba naintindihan?
Sir, yung R squared po, saan napunta?
R squared is, di ba, an arbitrary constant siya, right?
Okay po.
Okay, so since constant siya, if we are to differentiate this, derivative ng constant is 0, right? So kaya nang wala na siya. Okay, sige.
Okay.
Any more questions? Okay, guys?
Sir,
Yes.
same process lang siya kapag nasa y-axis naman po yung mga circles.
Sige, bigyan ko na kayo ng parang idea kung ano mangyayari. Sige, stop share muna ako para makita niyo yung mukha ko. Joke lang. Mag-on tayo ng whiteboard. Okay, now, same process lang, pero yung involved kasi dyan, unknown function, right? Nakita niyo ba yung whiteboard?
Yes po, sir.
Ang pangit lang ng drawing ko, sorry. Burahin ko ulit. Ayusin natin yung drawing. Papahiya tayo nito eh. Okay, lahat ng circles daw. All circles, or family of circles, ang center ay nasa y-axis. So, yan. May small circle, big circle, big circle. Basta lahat ang center ay nasa yan, y-axis. So, ano yung fix dito? Yan, this is y, this is x. Ano yung nagbabago dyan? Di ba may center tayo na tinatawag na HK, right? No? So, yung radius, isa sa mga parameters na kasi nga hindi naman fix yung radius na nabanggit eh. Unless sinabi ko na all circles, circles with radius equal to 1. So, pare-pareho yan. Pag sinabing radius equal to 1, yan, sulat ko muna. So, ibig sabihin, tapos yung center ay nasa y-axis. So, pare-pareho sila ng size ng circle. Okay? Ibig sabihin, hindi na magiging parameter yung radius kasi fixed na siya. So, paano kapag ganyan? Isulat ko muna yung equation dito. So, x minus, ano ba yung x na value, yung h na value? 0, di ba? So, hindi mo na concern yung h dyan, yung sa hk. 0 to. Na-follow nyo ba? Yung k
Yes
naman
po,
yung
sir.
nagbabago. So, plus y minus k ka dyan. Okay, squared equal to, yung radius ba? Bawat value ba ni radius nag-represent ng isang circle? Of course. Kasi magkakaiba sila ng radius. So, you have r squared. So, you have two parameters, k and r naman. Ayun lang. Pero, expect mo na mag-iiba yung sagot kasi dito, y, di ba? So, kapag dinifferentiate mo to magiging 2y minus k times derivative nito is y prime. Right? So, ganun siya. Medyo may challenge ditong part na to. Okay? Pwede nyo gawin yun mamaya. Okay, I think nasa self or problem set nyo to eh. Ito naman 2x lang. Okay? So makancel mo na yung 2 dito. Ito naman ay 0. Tandaan na ito pa lang ay first derivative. Second derivative pa ulit kasi nga dalawa yung parameters. Nasundan nyo yung steps?
Opo, sir.
O ganun lang. Bago nyo i-differentiate, i-simplify nyo muna. Tanggalin nyo muna yung mga common dyan or pwedeng i-cancel. Ito naman, since fixed na yung radius mo sa equation dito is, ano guys? Sige, diham ko. Bigyan mo ako ng equation. Nito.
Sir,
Ano equation nito?
parang equation, sir.
Parang katulad nito. yung starting equation mo.
Sige, sir,
Nabigla
ikaw
ka.
na bahala, sir.
Bigla ka ba? Ito lang. Oh, gagayahin mo lang to, di ba?
Sige, sir.
X squared plus ano? Y minus
1.
K.
Ay, kay, sir.
K kasi hindi naman fix yung K mo, di
Apo.
ba? Squared. Yung fixed lang dyan is radius, di ba?
Yes, sir.
1. 1 squared or 1. So yan na. Ito, ano ibig sabihin nito? Ilang parameters dito? Ilang parameters?
Isa lang, sir.
Isa lang. Yun yung
Si
value
K
ni
po.
K. Ibig sabihin, bawat value ni K nag-represent ng isang isang fishball. So, ganun lang.
Yes, sir.
Okay? Nakuha nyo na yung idea ng parameter na yan. Fix na yung radius. Okay? So, pwedeng ganun yung mangyayari. Pwede rin, yung center nila ay nasa isang line. Diba? Kunyari, line na ang slope ay equal to 1. So, pwedeng lahat ng circle na to ay nandito sa line na to. So, ang tanong, pwede rin yung nag-tangent siya dun sa line. So, yun yung mga challenge na part. So, meron kayong problem set na magagawa niyo. Pag may tanong kayo sa problem set, huwag kayong hayang mag-chat sa akin. Okay?
Okay po, sir.
Sige.
Thank you, sir.
So, yun lang naman yung topic natin for today. So, hanggang doon lang yung coverage ng quiz ninyo. So, start tayo sa basically, ano lang naman basic concepts. So, multiple choice, true or false, identification, tapos may konting problem solving. Elimination by arbitrary constant. So, ayan. And the quiz is good for 1.5. So, ibig sabihin, dapat yung quiz ninyo na ibibigay ko, kaya ko siyang matapos in 30 minutes. Okay, kasi times 3 ng aking kakayanan, dapat yun yung ibibigay kong time limit sa inyo. Okay? So, you can answer the quiz anytime you want, basta bago mag-prelim exam. Ganun lang yun. So, that's it. So
Thank
I
you,
think
sir.
we're good. Now, you can show yourself before we say goodbye to each other and okay, so thank you again for attending this class.
Thank you, sir.
Okay, stop recording.
Thank you, sir.
Thank you, sir.